For my first question, I had to prove proposition 5.11. So before we can start with the three different parts of the proof, I'm going to set some boundaries in general. So the first part of the proof, I'm going to say, let V be a vector space. Finitely generated over F. And I'm also going to let W be a subspace of F. And I'm just going to recall a little reminder that the dimension of V is the number of elements in a basis of V. So now that we have that, I'm going to say let N equal the dimension of V. So now that I have this, we can go into the first part, and it's proving that W is finitely generated. So we're going to assume that W is not finitely generated. So then by proposition 5.3, W contains a linearly independent subset B. Which contains n plus 1 elements. But since B is also a subset of V, it can't have more elements than V, since that we know the dimension of V is equal to n. It makes a contradiction. So this proves that it has to be finitely generated. Then we move on to the second part, which is every basis of W can be extended to a basis of V. So at first we're going to let B be a basis of W. Thus B is a linearly independent set of elements of V. So then we can say by proposition 5.7, we can now extend it to a basis of V. And then the last part, dimension of W is less than or equal to the dimension of V with equality when and only when W is equal to V. So since we know every basis of W can be extended to the basis of V based off of the second part of this proof. The number of elements of a basis W cannot be greater than the elements of basis of V. That is where we get the dimension of W has to be less than or equal to the dimension of V. If we have equality, then any basis of W is also a basis of V by the second part again. So then we have W is equal to FB, which is equal to V.